one more thing we need to do for your chapter 4, okay? We are on the page 34, section 4.7. We are learning the second thing in your class, which is graphing linear equations and inequalities. Okay? First thing was what? Solving linear equations and inequalities. Now we are graphing them, right? So let's review some inequality symbols. What do you think? Inequalities means what? They are not the same, not equal, or greater than, or equal to, less than, or equal to, right? So let's check. We also know for a linear equation, we have 3 forms, right? Then let's focus on standard form. Standard form of linear equation is what? Ax plus by equals c, right? And a, b, c are real numbers. And a, b cannot be both 0, right? So, what do you think the linear inequality would be? Then you go with those symbols, right? by and c, then that would be what? Usually we don't use this, we just compare. We use those greater than, or equal to, less than, or less than and equal to, right? Also, A, B, C are the same restriction for your inequality as well. So, let's see how we are actually graphing those inequality thing, right? So remember, for the one-dimensional world, okay, so for the one variable world, for x, if x is some number, then you have an answer, right? Another one is if x is, say, bigger than 5 for inequality. So how many answers you have? Infinite, right? Because that's 5, anything 6, 7, 8, all the way to infinity. So we cannot show the answer by just writing out. We have to show with what? Graphing or interval notations, right? So that will be to infinity. Okay, but for the two-dimensional world, then 2 variable, we have a linear inequalities. So we have a linear inequality. So let's see, if I have x plus y less than 5, how am I going to do it? So same thing, as x bigger than 5, you have, many solutions. You cannot just write it out, you have to do the picture. Okay, same thing, if x is, say, 2 and 7, that's, not less than 5. Let's do 1 and 1, less than 5, right? 2 and 2, less than 5. -3 and -3, still less than 5. Many solutions. So for the inequality, right? So we cannot show it. We have to do the graphing like the one variable world. So what do we do first? Okay, so we have to do the graphing with two-dimensional world, right? However, first there is a boundary condition. Okay, so first step, what do? You write down the boundary condition, which is what? X plus 5 equals x plus y equals 5, right? So it's a boundary condition. So how do we graph this one? We use our t-table, right? 0, 1, 2. X is 0, y is 5, you plug in. For x is 2, y is 3, right? Things like that. Then what do? You will graph the line 0, 5 and 1, 4 and 2, 3. Okay, so that's your boundary condition. Just like your x bigger than 5, then your 5 is your boundary condition. One side will be bigger, one side will be smaller, right? And if it's 2 variables, then the line will be your boundary condition. If it is no equal sign, then you just use dash line, okay? Just like here, if it's no equal sign, you use a parenthesis. Otherwise, you use what? Bracket. So for the 2 variable world, then no equal sign, you use dash. If it has equal sign included here, then you use solid line. Then this line will make left and right, right? Just like here, left and right. So you have to choose an area which it will work. One of them will work, right? So how do you know which one it will work? So second step, so you will do the what? Test point. Okay? If the point work for the inequality, that means that side work, right? Just like this one, point work, the point works on this situation, then all the things along with that side will work. So easiest point, you just use 0, 0. So if we use 0, 0, right, for the test point, what do you think? Will that work? So you do 0 plus 0, is that less than 5? You say yes, right? Yes, that means what? You will shade the area, okay, including we should say shade the area containing, that's better, containing the test point. Is that right? Because this point works, that means everybody along with the same side will work. That's how you will do it. Okay, that's how we do what? Answer the question for the inequality. Then we will show the solutions by graphing, because there is no just one point. Okay, there are many points, so we have to do it by the picture. So second one, greater than or equal to. So you have equal sign, then you will do the solid line. How should we start? find the boundary, right? So the boundary would be what? Your equation. Okay, so let's see. We can just plug in the points. So we do what? X and Y, 0, 1, 2. You just plug in 0, that's 0, Y is -3, right? Then plug in 1, that would be 2. Move 2 over would be 1. Negative Y is 1. Then Y would be -1, right? Then you plug in 2, that's 4. -4 on both sides, -1. Negative Y equals -1, so that would be 1. So that's your boundary condition. So we graph it 0, 1, -3, right? 0, -3. And 1, -1, right? 2 and 1. That's your boundary line with what? A solid line, right? So we choose left or right. We have to decide by testing just a simple point. This point looks easy to test. So we use what? Test point 0, 0. Okay, so you plug in the original. 2, 0 minus 0, is that bigger than 3? 0 minus 0? Not really, right? So it's no. So if it's no, we will what? Shade the area not containing the test point, right? So this one doesn't work. You shade the opposite side. That means the opposite side will work, and this side will not. Right? Okay. Then take a look. Next one. On your page is 35. So it's x less than 2y. That's C. So how should we start? Find the border, right? The boundary. So you use what? Find this way. Okay, so what do we do? So we do that, x and y, 0, because multiplied by 2, I use 2. Okay, so what do I have? x0, y0, x is 2, y is 1, and 2, right? So we have 0, 0, 0, 0, and 2, 1, right? 2, 1, and 4, 2, 4, and 2 here, 4, 2. Then you connect the line with what? A dash line now, right? Because there is no equal sign on the boundary. Okay, then what do we do? Choose the side, right? So which point would be easiest for you to do the testing? Oh, not 0, 0, because 0, 0 is right on here. We have to choose sides, right? This one or this one. So you don't want to use that point. Okay, so how about just 2, 2? I can use here. Here it looks easy. So that would be 0, 2. How's that? Test point. So I use test point 0, 2. See if it works. Okay, plug in. So it's 0 less than 2 times 2. Yes. So you will shade the area, right, containing the working point. If it works, you use that area. If it doesn't work, what do? You use the opposite area. Is that right? Right? So, what are we doing? We are graphing the linear inequalities right now. Right? If we have more than one answers, bunch of them, and actually infinite, then we will use the graphing pictures to show the answer. Okay? So, what do you think? First step, find the boundary condition, which is what? The line, right? Put the equal sign there to see, which area you are going to choose. So, what do you think? That's a special case. There's no x, and x is running free left and right, so it will be horizontal, right? 1, 2, 3, horizontal. So we use dashed line or solid line. A dashed line. For no equal sign in the original inequality, right? Then, next step, choose a test point. What do you think? How about just choose here, 0, 0. So y is 0, right? Is 0 greater than 3? No. Right? If not, you will shade the area not containing the test point. Right? So you will shade this area. Is that right? Not too bad, right? Manageable. Let's look at another special case, right? So, first step, find the boundary, find the border, right? X is 2. So, no y's, that means y is free up and down, so you will have what? A vertical line, right? With equal sign here, so we do solid line. Then, next one, find a test point. Which one looks easy? How about this one? Right? Does that work? So test the original for x. X is 0, so is 0 less than or equal to 2? Yes. So if it's yes, you will shade the area, right, containing the test point. So what do you think? You are going to shade area left or right containing, so that would be this area, right? So what are we doing? We are graphing linear inequalities. Okay, So for this chapter, 2 parts, right? One is what? Graphing linear equations. Another one will be what? Graphing linear inequalities, right? So this would be for the section 4.7.